The story begins with one of the rarest and most powerful cars ever built, the Bugatti Chiron Per Sport, a machine that represents the peak of modern automotive engineering. Only a very small number of these cars exist in the world, and each one costs millions of dollars to own and maintain. This is not just a car. It is a carefully designed hypermachine built with extreme precision, carbon fiber structure, and a massive W16 engine that produces unbelievable power. Every part of it is controlled, tested, and approved by the factory in Molsheim, France. Owners of such cars are usually expected to follow strict rules when it comes to repairs and maintenance. Even a small issue is normally handled by official Bugatti technicians, not independent garages. This is because the car is so advanced that even minor mistakes can lead to serious safety risks at extremely high speeds. In this story, however, everything changes when one of these rare cars gets destroyed in an accident. The owner, a young businessman living in the United States, crashes his Bugatti only weeks after receiving it. The damage is severe, and the car is declared a total loss by Bugatti's own expert who flies in to inspect it. According to the factory, the structure of the car is too damaged to repair safely outside their facility. Insurance agrees, and the car is sent to a salvage auction. At this point, most people assume the story ends here. A destroyed hypercar is normally written off forever. But what happens next becomes the beginning of one of the most controversial rebuild projects in automotive history. The car is bought back on the auction by the same owner for nearly $2 million, an amount that shocks even experienced car collectors. Instead of accepting the factory's decision, he decides to attempt something almost no one believes is possible. He wants to rebuild it, not in a factory, not with official support, but in a private workshop using independent tools, engineers, and creativity. This decision sets the stage for a conflict that will grow far beyond a simple repair job. It becomes a challenge between independent engineering and one of the most powerful car manufacturers in the world. The question now is not just whether the car can be fixed, but whether modern automotive control systems are too strict for innovation outside factory walls. After the crash and auction, the story quickly becomes more serious. The damaged Bugatti is no longer just a broken machine. It becomes a symbol of a bigger debate in the automotive world. The factory believes the car should never be repaired outside official control due to safety concerns. They argue that the carbon fiber structure could have hidden damage that cannot be seen with the naked eye. At very high speeds, even the smallest structural weakness could lead to catastrophic failure. Because of this, Bugatti strongly discourages independent repair and offers only two options to the owner. One option is a full factory repair, which would cost a massive amount of money and take a long time. The other option is to send the car back to the factory completely and allow them to rebuild it under strict supervision. Both options keep full control in the hands of the manufacturer. However, the owner refuses both choices. He believes the car can be repaired outside the factory with the right skills and tools. This decision creates tension between him and Bugatti. The situation escalates further when a well-known automotive content creator, Mate Armstrong, enters the story. He is known for rebuilding damaged and high-performance cars using independent workshops and creative engineering solutions. When he sees a Bugatti, he decides to take on the challenge. But even he understands the risk involved. The damage is not just cosmetic. The engine has shifted, the chassis is stressed, and internal components are broken in ways that require deep technical knowledge to repair. Despite this, he accepts the challenge. Soon after, Bugatti takes action by restricting access to official parts through the vehicle's identification number system. This means that no authorized dealer can supply replacement components for the car. This move effectively blocks traditional repair methods and forces the rebuild team to find alternative solutions. The conflict is no longer just about fixing a car. It becomes a debate about ownership control and whether manufacturers should have the power to limit repairs on products that legally belong to customers. The situation is now turning into a public controversy, attracting attention from car enthusiasts, engineers, and legal experts around the world. As the rebuild begins, the complexity of the project becomes clear very quickly. The Bugatti is not a normal car that can be taken apart with standard tools. It is built using a carbon fiber monocoque structure, which is extremely strong, but also very sensitive to damage. To repair it properly, manufacturers usually use specialized alignment systems and factory equipment that ensure every part is placed back in perfect position. Without this equipment, even a small error can change the way the car handles at high speed. The independent team working on the car faces this challenge head-on. They decide to split the car into two sections to access the damaged internal structure. This is an extremely risky move because it requires separating the main chassis, drivetrain, and multiple systems at once. Every bolt, pipe, and electrical connection must be carefully removed in a specific order. One mistake can make the car impossible to rebuild. As the disassembly continues, they discover that the damage inside is worse than expected. The engine mount is broken, the gearbox housing is cracked, and multiple pipes are crushed. The impact from the crash has pushed the engine out of its original position. Despite the severity, the team continues working methodically. They document every step, measure every part, and try to recreate factory-level precision using independent tools. This part of the story shows the difference between theory and real-world engineering. In theory, the factory is right. This kind of repair should be done in controlled conditions. But in practice, skilled engineers are attempting to recreate those conditions outside the factory using knowledge, patience, and problem-solving. This creates tension not only in the story but also in the audience's mind. People begin to question whether factory control is truly necessary or whether modern engineering knowledge is strong enough to handle such tasks independently. The rebuild is no longer just about fixing a broken car. It is now a test of whether human skill can match industrial systems built by one of the most advanced car manufacturers in the world. As work continues, one of the most important moments in the rebuild arrives. A critical metal bracket that connects the engine to the gearbox is found to be completely broken in two pieces. This part is extremely important because it holds two of the most vital systems in alignment. Without it, the car cannot function safely. The factory does not supply a replacement because the vehicle has been locked in their system. This means a team must either repair the broken part or create a completely new one without official support. This is where a specialist machinist enters the story. He is not a Bugatti engineer or a famous designer. He is simply a highly skilled metal worker who understands how to repair complex materials. The broken part is sent to him for analysis. The challenge is difficult because the material used is a special alloy that reacts unpredictably to heat. If the welding process is done incorrectly, the part could crack further instead of repairing. After careful study, he decides to attempt a repair. The process requires extreme precision. Both broken ends must be perfectly aligned, cleaned, and prepared before welding. Even the smallest mistake in temperature or angle could ruin the part permanently. After several attempts and careful control, the weld holds successfully. This moment becomes a turning point in the project. It proves that with enough skill and patience, even parts considered non-reparable by manufacturers can sometimes be restored. However, this success does not end the debate. It actually increases attention around the project. Some people see it as a breakthrough in independent engineering, while others see it as a dangerous example of bypassing factory safety standards. The story continues to grow in complexity, attracting opinions from both sides of the automotive world. As the rebuild progresses further, the team starts reconstructing the car piece by piece. New systems are designed, damaged wiring is replaced, and missing components are sourced through alternative methods. Some parts are recreated using modern 3D scanning and printing technology, while others are repaired manually. The exhaust system is redesigned to improve performance and sound, giving the car a more aggressive character than the factory version. Slowly, the vehicle begins to take shape again. One of the most impressive moments comes when the two halves of the car are prepared to be joined back together. This process is extremely delicate because everything must align perfectly without factory tools. Suspension points, engine alignment, and structural connections all depend on precise measurement. The team works slowly, checking every detail multiple times before making final adjustments. When the sections finally come together, it becomes clear that the rebuild is reaching a critical stage. The car is no longer just a collection of broken parts. It is becoming a functional machine again. However, even at this stage, problems remain. Small leaks, alignment issues, and system warnings continue to appear. Each issue must be solved immediately to avoid long-term damage. This part of the story highlights the reality of engineering projects. Success is not a single moment, but a long process of solving problems one by one. The rebuild is no longer just about proving a point to the manufacturer. It is about completing a machine that was once declared impossible to FIX as the car nears completion. Public attention grows rapidly. Videos of the rebuild spread online, and discussions about manufacturer control versus independent repair become more intense. Many people admire the skill and determination shown in the project, while others question whether it is safe or responsible. The manufacturer maintains its position, stating that certain repairs should only be done in factory conditions to ensure safety at extreme speeds. Meanwhile, the independent team continues working toward finishing the car. When the engine is finally started after months of work, it becomes a major moment in the story. The engine fires up smoothly, without major errors, and settles into a stable idle. This confirms that the rebuild has reached a functional level. The sound of the engine is powerful and raw, especially after modifications to the exhaust system. The car moves under its own power for the first time since the crash, marking a symbolic victory for the team. However, even this success does not completely settle the debate. Questions remain about long-term safety, structural integrity, and responsibility. The story becomes more than just a technical achievement. It becomes a discussion about the future of automotive repair rights. In the final stage of the story, the rebuilt Bugatti stands as both a success and a controversy. It represents what independent engineering can achieve with enough skill, determination, and creativity. At the same time, it raises serious questions about safety, manufacturer control, and legal responsibility. The car that was once declared a total loss is now running again, proving that some limits can be challenged. However, the debate is far from over. Should manufacturers have full control over repairs, or should owners have the freedom to rebuild their own vehicles using independent methods? This question remains unanswered. What is clear is that this project has changed the way people think about hypercar repairs. It has shown that modern technology like 3D printing, advanced machining, and cross-platform part sourcing can potentially replace factory dependency in some cases. But it has also shown that extreme engineering still carries risks that cannot be ignored. The story ends not with a final answer, but with a question for the future. How far should independent repair go? And where should the line be drawn between innovation and safety? After the first successful start of the rebuilt Bugatti, the atmosphere in the workshop changes completely. What was once a silent, damaged shell of a hypercar is now alive again, idling with the deep, powerful sound of its W16 engine. For the team, this is not just a technical milestone. It feels like proof that months of hard work were not wasted. Every late night, every broken part, every failed attempt now leads to this single moment of success. But even though the engine is running, the project is far from complete. A running engine does not automatically mean a safe or fully functional car, especially when it comes to a machine capable of speeds above 250 miles per hour. There are still many systems that need testing, calibration, and correction. The suspension must be checked for alignment issues. The braking system must respond perfectly under pressure, and the electronics must communicate without errors. Each of these systems is critical because at high speeds, even the smallest fault can become dangerous. The team begins careful testing in controlled conditions, slowly increasing confidence with every step. At the same time, pressure from outside the workshop continues to grow. People online are watching closely, analyzing every update, and debating whether this rebuild should even be allowed outside factory control. Some viewers are impressed by the engineering effort, while others remain concerned about safety risks. The project has now become more than just a rebuild. It is a public experiment in automotive limits. Every update adds more fuel to the discussion, and every successful mistake is judged by thousands of eyes around the world. Despite all this attention, the team stays focused on one goal: making sure the car is not just working, but truly roadworthy and stable under real-world conditions as testing continues. Small issues start to appear, which is completely normal in a project of this scale. No rebuild of such a complex machine is ever perfect on the first attempt. Minor fluid leaks, sensor warnings, and calibration errors show up during early checks. Each issue requires careful diagnosis because modern hypercars rely heavily on electronic systems working together. A single faulty sensor can affect engine performance, safety controls, or driving stability. The team works through these problems one by one, using a mix of experience, technical knowledge, and trial-and-error adjustments. What makes this process more challenging is the lack of official factory support. Normally, manufacturers provide diagnostic tools, technical data, and direct guidance for repairs. In this case, the team must rely on independent methods, cross-referencing parts from other vehicles, and using advanced scanning tools to understand how each system behaves. This slows down the process, but also forces creative problem-solving. Over time, most of the issues are resolved, and the car begins to behave more like a properly restored machine. However, the uncertainty never fully disappears. There is always a question in the background. If something goes wrong at high speed, who is responsible? The manufacturer believes it should not be rebuilt outside their system, while the independent team believes ownership includes the right to repair. This conflict continues to follow the project even as the car improves. It shows that the rebuild is not only technical, but also philosophical. It challenges the idea of control in modern automotive design and raises deeper questions about who truly owns a machine once it is sold. As the project moves closer to completion, the story begins to attract attention beyond the automotive community. It is no longer just car enthusiasts who are watching. Engineers, journalists, legal experts, and technology observers are also following the rebuild. Many see it as a real-world case study of how modern tools like 3D printing, digital scanning, and independent fabrication can challenge traditional manufacturing systems. Others see it as a warning about the risks of modifying highly advanced machines without official oversight. The debate becomes larger than the car itself. It turns into a discussion about how industry should handle repair rights in the future. In many modern products, from phones to tractors to high-end cars, manufacturers are increasingly controlling access to parts and repair systems. This rebuild highlights what happens when someone tries to step outside that system. At the same time, it shows how far independent engineering has come. Tasks that once required factory-level equipment are now being done in private workshops using a combination of skill, technology, and creativity. This shift is important because it suggests that control over repairs may not remain centralized forever. As tools become more advanced and accessible, independent repair may become more common, even for highly complex machines. The Bugatti rebuild becomes a symbol of this possible future. Whether people agree with it or not, it proves that boundaries in engineering are constantly being tested and redefined. Near the end of the rebuild process, the car reaches a stage where it can finally be driven again under controlled conditions. This moment is extremely important because it moves the project from static testing to real movement. The first low-speed drive reveals both success and remaining concerns. The car responds correctly to steering, acceleration, and braking inputs, showing that the core systems are functioning together. However, the team remains extremely cautious. Every sound, vibration, and reading from the dashboard is monitored carefully. This is because high-performance vehicles behave very differently at low speed compared to high speed. A car that feels fine at 30 miles per hour might behave unpredictably at 200 miles per hour if something is even slightly off. Despite this, the initial driving tests are considered a success. The rebuilt systems are working, and the car is no longer just a stationary project. It is now a functioning vehicle again. This moment is celebrated quietly in the workshop, not with loud excitement, but with a sense of relief and accomplishment. At the same time, the broader debate continues online. Some people praise the achievement as a breakthrough in independent engineering. Others remain skeptical, pointing out that factory-level validation is still missing. This split in opinion reflects the core tension of the entire story. Innovation versus control, independence versus safety, and creativity versus regulation. The car itself becomes a physical representation of this debate and the final reflection of the story. The rebuilt Bugatti stands as a powerful example of what modern independent engineering can achieve. It is not just a repaired car. It is a challenge to long-standing ideas about who has the right to fix complex machines. The project shows that with enough determination, knowledge, and technology, even a machine declared unrepairable by its manufacturer can be brought back to life. However, it also shows why manufacturers impose strict rules in the first place. High-performance engineering is not just about making something work. It is about making sure it works safely under extreme conditions. This balance between freedom and safety is at the heart of the entire debate. The story does not give a simple answer. Instead, it leaves viewers with questions about the future of technology and ownership. As machines become more advanced, will users gain more freedom to repair them, or will manufacturers tighten control even further? The rebuilt Bugatti does not solve this problem, but it makes it impossible to ignore. It stands as proof that the limits of engineering are still being tested, and the conversation between innovation and control is far from over as the rebuilt Bugatti continues to prove itself in real-world testing. The emotional weight of the project starts to shift. At the beginning, this was simply seen as a technical challenge, a damaged hypercar being brought back to life in an independent workshop. But now it feels much bigger than that. It has become a symbol of how far modern engineering can go outside factory systems when enough skill and determination are involved. Every successful test drive adds more confidence, but it also adds more attention. The story is no longer just being followed by car enthusiasts. It is now being discussed in engineering forums, legal circles, and even among people who normally have no interest in cars at all. The reason is simple. This rebuild is challenging the idea that only manufacturers can safely repair their own creations. It shows that knowledge is no longer locked inside factories the way it once was. With modern scanning tools, global parts networks, and advanced fabrication methods, independent engineers are now capable of solving problems that were previously considered impossible outside official systems. At the same time, the project also exposes the limits of this independence. Without factory data, official testing tools, and manufacturer approval, every step carries uncertainty. Even when things appear to be working, there is always a question in the background about long-term reliability. This tension keeps the story balanced between success and doubt. It is not a simple victory or failure. It exists in a space in between, where progress and risk are both present at the same time. While the Bugatti rebuild gains attention, a second layer of impact starts to emerge that goes beyond just one car or one workshop. Other car owners, mechanics, and independent garages begin to look at the project differently. Some see it as inspiration, believing that they too might be able to repair or rebuild high-end vehicles that manufacturers normally restrict. Others see it as a warning, arguing that not all repairs should be attempted outside controlled environments. This division reflects a much larger global debate about repair rights. In many industries, as discussions grow around the rebuild, one thing becomes very clear. This project is no longer just about a single Bugatti anymore. It has started to represent a shift in how people think about ownership and control in the modern automotive world. Traditionally, when someone bought a high-performance car, they were also accepting that most repairs would be handled by the manufacturer. This system was built around safety, precision, and maintaining strict engineering standards. But the Bugatti rebuild challenges that idea by showing what happens when a skilled independent team decides to take full responsibility for a machine that the factory itself declared unrepairable. Supporters of the project argue that ownership should include full freedom to repair, modify, and restore any product legally purchased. They believe that knowledge and tools today are advanced enough to allow safe independent repairs, even on complex machines. Critics, however, strongly disagree. They point out that hypercars operate at extreme performance levels where even the smallest mistake can lead to serious consequences. From their perspective, factory control is not about limiting freedom, but about preventing risk. This disagreement creates a wider conversation that goes beyond cars and touches on technology, consumer rights, and the future of engineering itself. The Bugatti project becomes a real-world example of this conflict, showing both the possibilities and the dangers of stepping outside traditional systems. Eventually, the rebuilt Bugatti reaches a stage where it is no longer just a workshop project, but a fully functioning machine that can be demonstrated in real conditions. The car starts, moves, and responds like a hypercar should. It is no longer the destroyed vehicle that arrived from a salvage auction. It is now something rebuilt through independent effort, problem-solving, and technical creativity. However, even at this stage, there is no final sense of closure. The manufacturer still maintains its position that such repairs should only be done under